application of integration, and there will be now differential equations for them, for differential equations. For example, for them it's the separation of variables. So if you have, for example, d of v by d of t, they usually involve time. Let's say you have, say, f of t times g times g of v. So what you do, you separate the variables, so you go 1 divided by g of v equals times dv, and you get f of t times dt, and then you integrate two parts of the equation separately, this one by dv, this one by dt. That's it. So separation of variables. Separation variables. Apart from that, well, that's for it, and there's one more place where you can use them. For example, they're called how to find numerical solutions to differential equations, and we use numerical solutions to differential equations using Euler's method. So what the Euler did, he said, instead of, for example, you have a differential equation, you don't know the curve. So the point is, this curve you don't know. Say that its equation you don't know. So here you have x-axis and you have y-axis, but what you do know is the first differential of that curve. So if you know the first differential of that curve, and that being f of x and y, then you can find the proximate. So if you take a point here called x0, and on the x-axis, and on the y-axis is y0. So if you know these points, you do know them, and you do know this bit here, the differential equation, then you can estimate where the points are, every next point of this on this curve. It won't be just on the curve, but it will be close to it. And how you can estimate it? How you put a tangent here. That's the tangent is that. That's your tangent line. So the coefficient of this tangent line. So you can get the next point that is close to being on the curve, but not. It's not in point x1 if you can take it from the tangent. So y1 is on the tangent. So if you then going further, if you're going further, decide that you want this point here, then you can again put a tangent to this point here and find that point on the tangent. So the point's approximation of the curve, instead of being on the curve, they are on the tangents. So for example, it will be clearer. So if you say that point x0 and this increment here we'll call a h. So if you say that we can get point x1 is the same as x0 plus h, then we can get y1 knowing the differential here. So we can have, that's the coefficient of the on the tangent line, right? So we can get it like, if you say that you do know this one, we said that, and then you can plus and use dy per dx there times h. So dy by dx times h. So that's how you get point number 1. And similarly, point number 2, you will get knowing point number 1 plus, of course, x2 is equals x1 plus h. So dy by dx times h. But this is now of the point. So here you had the point x0. So you will x0 and y0, tangents in this one, and the tangent here will be point x1, y1. So this one here can be written as, taking account this, f of x1, y1, or this one here, f of x0, y0. So use this differential, what the coefficient, what is the slope is of the tangent in that point. That's the first. So you do know, you do know this, you do know this, and you start from there. So knowing this and knowing x0, you get x1. Knowing x1, you get x2. And similarly knowing the point x0, y0, the same, you get the other one. So that will be more clear on an example. Let's do an example. Takes time to get some space on this board. Okay, now we can do an example. For example, we say that the point like 2, 1 is or a curve which we don't know, that curve being called whatever, f of x, we don't know that curve. And the point is, this is our point x0, y0 is y0 and x0, and it's on that curve. So and we know that dy, we also know that dy, that's given to us, so that's given, and that's given. Dy by dx is, say, let's say y plus 2x. So, and the interval of h, we'll say it's 0.1. Then what we get from, so that's dy by dx. So how are we gonna get point number 1? Point number 1, x1 is x0, which is 2, plus the increment. So it's 2.1. How are we gonna get point y1? y1 will get y0, which is 1, plus we have the increment times, so the increment is 0.1, and we go times, what's our differential on this point? So we need to find the differential in point differential dy or dx would be in where the point is 2, 1, so that would be our formula for the differential is there. So it's 2, 1 becomes 2 plus 2 is 1 plus 4, that's 5 times 5. So what do we get? 1.5. So this our pair, second pair x1, y1 here is equal to 2.1, 1.5, and so on.